Hi everyone, this week's lesson 9 extra practice for ECON315 guided study group. The lesson is on a lot more, more net present value and equilibrium, so I'm going to get started right away. Number 1 says the maximum cost of moving. So suppose that a baseball player eligible for free agent status signs a contract with a new team that promises to pay him $100,000 more than his current team for each of the next 3 years. Assuming the discount rate is 6%, what is the maximum the current cost of moving could be and still have this investment be worthwhile? So again, what we've seen already a couple times with net present value is some kind of word problem that we have to figure out. So as always, I'm going to just write out the given information. So the new team is offering to pay him $100,000 more. It's for the next 3 years. And the discount rate, which we know is R, is 6%, which comes out to be 0.06. And then they're asking what's the maximum the current cost could be. To make it still worthwhile. So to make the investment still be worthwhile would mean that the net present value is positive. Remember, when our net present value is positive, we're going to invest. When it's negative, we're going to reject. So again, this is a good example of paying attention to the wording of the problem. So we can see that they were talking about the next 3 years. So that means that all the present value terms in the equation we're going to discount because they're talking about the next 3 years. But then they ask us what the current costs are. So with the current costs, we're not going to discount that. Remember what I said last lesson about how anything that's happening in this period or currently or present isn't going to be discounted, but once they talk about the next year or over X amount of years, it will be discounted. So once again, we just have to be able to set up our equation. So net present value is just a summation of the costs and benefits of this investment. And then we can use our present value equation of PV equals the future value over 1 plus R raised to the T power. So it's just going to be a summation of this equation for each term or each period or each year, however you want to think of it or however the problem's laid out. So we're trying to find the maximum the current cost could be, so I'm going to denote that as X. And then setting up this equation, we can go with net present value equals, so the first year would be written out as 100,000 because remember the future value portion of this equation is just the incremental earnings. So our incremental earnings would be 100,000 because this new team is paying them $100,000 more. So that's the difference. That'd be the difference between the two salaries. We don't actually need to know the full salaries at each team. So again, we have the incremental earnings in the numerator, and then we have 1 plus R. So this becomes 1.06. And that gets raised to the first power for the first year. Then we do the same exact thing for the other 2 years. So be raised to the second power and then raised to the third power to represent the second and third years that this person is playing. And then we have to factor in our x into the equation. So costs are going to be negative, and then since they're current costs, they don't need to be discounted. So we can just add it on as minus x. And then they wanted the maximum the current cost could be and make it worthwhile. So that means that it'd be greater than net present value. So you can just think in the back of your head that this equation needs to be greater than 0. But you don't have to actually factor that into your equation. Instead, what we can do to solve for x is just set this equation equal to 0 and then solve for x. So I think I did it in a problem last week. What I'm going to do is factor this $100,000 out to leave 1 over 1.06 plus 1 over 1.06 squared plus 1 over 1.06 cubed minus x equals 0. And then plugging this part in the brackets into your calculator, I got 0.943 plus 0.890 plus 840. And then adding each of those 3 decimals together and multiplying by 100,000, it comes out to 267,300 minus x equals 0. We can just add the x to the other side, so we get a final answer of 267,300. So what this number tells us is that his current costs can be no greater than $267,300 for him to decide to move to this new team for the investment to be worthwhile. If it's anything greater than this number, then the costs are going to outweigh the salary that's being discounted, and we'd get a negative net present value and he wouldn't take the offer. If it's anything less than that, then the discounted benefits are still going to outweigh the cost, and the investment would still be worthwhile and he would take it. So this one's a pretty simple net present value problem. That was all that was needed. So I'm going to move on to the next one. So number 2, minimum necessary salary to move. Dr. Joel is a doctor in a large metropolitan city in the U.S. He earns $100,000 a year and plans on working 3 more years and then retiring. A remote rural town in the state in which he resides is in desperate need of a doctor and offers Dr. Joel a job. If he moves, he will still only work for 3 years, thereby not adjusting his retirement plans. He would incur $15,000 in sidekick costs if he moves due to the disutility he experiences from moving to such a remote location. Dr. Joel's discount rate is 5%. What is the minimum annual salary that the remote town must pay Dr. Joel per year for him to accept its job offer? So compared to the last problem we had to figure out the current cost to make it worthwhile. Now in this problem, they're giving us the current cost. We have all the same elements. They're still giving us but they're giving us the current cost. We need to figure out essentially the incremental earnings portion of the equation. In both problems, we're still trying to find how to make it worthwhile for that net present value to be positive. But we're just finding 2 different parts of the problem in each example. So essentially they're set up the same way, but you're finding different things. So this doctor is currently earning $100,000 a year. He needs to work 3 more years. Again, look at the wording. They were talking about working the next 3 years. If he moves, moving would incur $15,000 in site kit costs. I don't think I spelled that right. and the discount rate is 5%, which comes out to be 0.05. And then again, to accept the job offer, the net present value needs to be greater than 0. So setting up this equation, we're just going to have a summation of each of these terms for each period. So they wanted to know the salary the other firm must offer. So if you remember, incremental earnings is just the difference of earnings between two places. So in this case, we don't have that difference, but we have what he's currently earning, then we're trying to find the firm of the other one. So in this case, our incremental earnings is just going to be X minus 100,000. And that's because X would be the salary the other firm is offering. And then 100,000 is what he's currently working at. So if we find the salary the other firm must offer, if we would plug it back into the equation, this would become the difference of earnings, which is the incremental earnings that we would usually be using in this equation. So in the last problem, they gave us the difference of earnings, which also happened to be just $100,000. In this problem, they don't give us incremental earnings. They give us the full salary. They're structuring it as needing to find the difference between the full salaries of the two places instead of the difference of earnings. Hopefully that makes sense. It's a little weird to go back and forth between the different kinds of problems, but I think you'll be able to understand it. So then back to setting up this problem, we'll have 3 periods or 3 terms like we did in the last one, and then we'll factor in the current cost of moving. So we have X minus 100,000 over 1.05 raised to the first power for the first year that he works, X minus 100,000 over 1.05 raised to the second power for the second year that he works, and then the same thing again but raised to the third power. And then the current cost of moving would be $15,000, so that doesn't get discounted, and we can just tag it on to the back. And then again, this would have to be greater than 0 for it to be worthwhile, but for solving purposes, we can just set it equal to 0. So as I did in the last problem, I'm going to factor this out, this X minus 100,000, so we get 1 over 1.05 same thing squared, 1.1 over 1.05 cubed minus 15,000 equals 0. And then the next step would be to solve for these, or simplify these fractions down. So plugging that into your calculator, I get 0.952 plus 0.907 plus 0.864 minus 15,000 equals 0. And then I'm going to continue up in this corner that I just erased stuff for. So after we simplified those fractions down, we can then simplify the decimals into one term and then multiply that, distribute that, and multiply it by the x minus 100,000. So simplifying all of that down, I got 2.723x minus 272,300 minus 15,000. And that would all be equal to 0. Continuing to combine like terms, we have 2.723x minus 287,300. And then adding the 287,300 to the right and then dividing by 2.723, I get an x of 105,509. So this term we just found is the minimum salary the other firm must offer for his net present value to be positive and to take the job. So what I said earlier about the incremental earnings part, if we were to plug that x back into this equation, it would be 105,509 minus this 100,000, which then just becomes the difference of earnings, the incremental earnings we need to solve the equation. So it all works out. So you can see there's two different ways to solving this kind of problem for the incremental earnings. You can either use, like, if it's given, you can use the actual difference, but if the actual difference isn't given, then you can use the difference between the full salaries of the two places they're comparing. But this was just another net present value problem that was pretty straightforward. You just had to solve for something different than the current costs. So hopefully you were able to follow along. So then moving to the next one. Equilibrium with influx. Assume the labor demand for unskilled workers in a city in Texas is given by labor demand equals 80 minus 2W. Labor supply curve of natives, non-immigrants, is given by labor supply equals negative 20 plus 8W, where W is the hourly wage. So number one, calculate the equilibrium level of employment and wage rate if there are no immigrants. So back to equilibrium. We haven't done this in a while, but hopefully you haven't forgotten it too much. So they gave us labor demand as 80 minus 2W, labor supply as negative 20 plus 8W. So number one, finding equilibrium. Remember, in equilibrium, labor supply equals labor demand. So we can just set these two equations equal to each other and then solve for the respective variables. So 80 minus 2W equals negative 20 plus 8W. Adding 20 to both sides, we get 100 on the left. Adding 2W to both sides, we get 10W on the right. Dividing each side by 10, we get an equilibrium wage rate of $10. Again, since we're in equilibrium, we can plug that back into either equation. I'm going to use the first one. So our equilibrium level of labor is going to be 80 minus 2 times our equilibrium wage, which is 10. So we have 80 minus 20 So we see that the equilibrium level of labor for natives is 60 workers. So again, this was for natives. So then part 2 says, suppose the arrival of Mexican immigrants shifts out the labor supply curve to labor supply equals -5 plus 8W. So calculate the new equilibrium level of employment and wage rate. So this is now for natives and natives and immigrants. So we changed our labor supply, but the labor demand stays the same. We solve it the exact same way, but with the new supply equation, so we still just set them equal to each other and solve for each of the variables. So the way I've set it up, we also solve for wage first again. So adding 5 to each side, we get 85 on the left, and then adding 2W to both sides, we get 10W on the right. Dividing by 10, we see that the equilibrium wage is now $8.50. And then plugging that back into either equation, I'm again going to use the labor demand equation. We have the labor equilibrium level of labor being 8 minus 2 times the equilibrium wage of $8.50. So this becomes an equilibrium level of 63. Now in this case, this equilibrium wage and level of labor is for the natives and immigrants. So the amount of people working is not solely natives. So this is natives and immigrants. So number 3, what has happened to the employment level of natives as a result of the immigrant arrival? So it's important to make those two distinctions of what the labor supply curve is in each, or who makes up the labor supply in each scenario, because at first glance you might say that the employment level of natives has gone up by 3, but that's not actually what happened. It's total employment has gone up by 3, but it's now a mix of natives and immigrants. So to be able to find the employment level of natives as a result of the immigrant arrival, what we have to do is take this new equilibrium wage of $8.50 and plug it back into the original labor supply curve of just natives. Because if we see how many natives are supplying their labor at the new wage rate, we can then compare that number to how many natives were originally holding jobs. So labor supply equals -20 plus 8 times 850. And it comes out to be a labor supply of 48. So what we see is that there were originally 60 native workers in equilibrium. Immigrants came and increased the total amount of employed to 63 at a lower wage rate. But now we see of those 63 workers, 48 of them are native workers. So the employment level of natives has decreased by 12. Because we originally had 60 and now we're at 48. So the employment level has decreased by 12. And then they asked what has happened to the unemployment rate as unskilled native workers. So even though the employment level of natives has gone down by 12, the unemployment rate is still 0 because the market's in equilibrium before and after immigration. So as I've said before, unemployment is when there's a surplus of labor. So if we were thinking of it graphically, it would be above that equilibrium point. But in this case, we're still in that equilibrium point. We're not at a surplus of labor. So the unemployment rate is still 0, even though 12 workers have lost their jobs. It's just that this wage, 48 people are supplying labor. That's how many people are being hired. There's no unemployment in the problem, even though it might look like it at first, but there's not because we're in equilibrium. Whenever the market's in equilibrium, the unemployment rate is always going to be 0. So I think that's all of number 3. So I can move on to the next one. So last one, finding the internal rate of return. Sue Ellen works for a large computer company. She expects to work this period and next period and then retire. Her current employer pays her $50,000 a year. A rival firm offers her the same job at a salary of $56,000 a year. However, Sue Ellen places a value of $10,000 on remaining with her current employer since she has many friends at her current company and does not enjoy meeting new people. Sue Ellen decides to reject the job offer. How much must Sue Ellen discount future benefits? So the first problem, we were looking at finding the current costs. Second problem, we were looking at finding that incremental earnings portion. And now we're finding the discount rate. So, and this one's a good example because it kind of combines what I said of the different ways to find the future value portion of the equation. So anyway, given information, she's working this period and next period. Currently, she's making $50,000 a year. And then the rival firm is offering her $56,000 a year. And then her site kit costs, she said, were $10,000. And then what's R? So they give us the full salaries for both firms. So we know now that the incremental earnings that we would use in our equation would be $56,000 minus $50,000, which comes out to be just $6,000. If you want, you could enter this whole thing into the future value portion of the equation if you wanted, but I think it's easier just to find the difference beforehand and then just put 6,000 in. So again, just setting up this equation is usually the toughest part. So it's going to be a summation of this present value term for the number of periods we're looking at. So they were talking about her working this period and the next. So this period means that it wouldn't be discounted. So it would just be the incremental earnings, which is 6,000. If you wanted to really use the whole equation, what you could do is 6,000 over 1 plus r to the 0, because a t of 0 is currently. So then when anything's raised to the 0 power, this turns into 1, so it'd just go back to 6,000. But if you wanted to think of it in terms of the equation, you can do it that way. But I usually just write 6,000 since it's this period, and I know it doesn't need to be discounted at all. And then we can add on the second term, which would be 6,000 over 1 plus r to the first power, because that would be the first year she's working. This period, next period. So we have the initial period and then the first period. And then the site kit costs aren't discounted because they're current, so we can just tag on the 10,000 and then to solve for r, we can just have this, set this equal to 0. So solving for this equation, on the left we see a 6,000 and a negative 10,000, so that becomes negative 4,000. Adding that to the right side, we can see it becomes a positive 4,000 on the right. And then on the left, all that's left is 6,000 over 1 plus r. We can get rid of this fraction by multiplying both sides by 1 plus r. So, like that. So then what we get is 6,000 equals 4,000 times 1 plus r. I'm going to simplify these numbers. So dividing each side by 4,000 gives us 6,000 over 4,000 on the left, and that simplifies to 3 over 2 equals 1 plus r. So we know that 3 over 2 is 1.5 minus 1 equals r, because I subtracted that 1 from the right. So 1.5 minus 1 is 0.5 equals r. And so we see that her discount rate is 50%. So for her to not accept the job offer, she must be discounting future benefits by at least 50%, which is a lot bigger than the other problems we've done, but that's what Sue Ellen decided to do. So again, this was just a little bit of setting up the equation correctly and then a little bit of algebra to find r. So these problems today were just a lot more net present value, one equilibrium that we haven't done in a while, but I think the hardest part with these net present value problems is figuring out what you're trying to solve for and then setting up the equation and really paying attention to that wording. So make sure you're focusing on that part, and I think you'll be good in your studying. So good luck.